At 07:15, the strike began. 4 Ukrainian drones launched from a tree line 8 kilometers deep behind friendly lines vectoring southwest toward a Russian. The last asset barely cleared the canopy when control signals flooded the local spectrum. That glaring electronic signature meant any adversary intercept unit would flag this launch instantly. Our operators were blind to the danger, but the enemy hunt had already begun. 20 kilometers north, a Russian R-93 four-direction-finding asset had been waiting since midnight. Externally, it looked like a standard military truck, save for the dish antennas on the roof, sweeping the spectrum hunting specifically for drone emissions. The second those command signals went, enemy signal intelligence classified the threat in a heartbeat, identifying frequency hops between 1.2 and 1.4 gigahertz, a clear signature of a hostile field control station. But tactically, one bearing solves nothing. A single line on a map extends to infinity. To fix the target, a second receiver 25 kilometers northeast intercepted the same signal. Where the lines intersect, the math becomes lethal. Both feeds hit a Borisoglepsk 2 command post, fusing the bearings using microsecond timing differences. Multiplied by just 23 seconds after the first uplink packet was transmitted, a precise grid coordinate emerged from their system. This data bypassed analysts entirely, routing directly to a fire unit. In modern peer conflict, electronic detection triggers immediate counterbattery fire. Striking so fast, the first rockets arrive before the drones even reach their handover point. Our operators, focused on 4 tiny icons crawling toward the tracks, had no idea an enemy rocket battery was already elevating its. The objective was brutally simple: intercept a fuel train bound for the Dovzhansk depot. Miss it and the next resupply won't roll for 70. That translates to 3 days of dry tanks of paralyzed supply trucks, dead generators, and of infantry forced to march on foot instead of riding in armor. But before we could strike that train or depot, a tactical crisis loomed right over our heads. 31 kilometers away, an enemy Grad battery received our coordinates. No bureaucratic clearance was required. Their launcher tubes whined as they elevated computers factoring in crosswinds before initiating the launch sequence. In the field, you hear it before you see it, the terrifying ripping roar of a rocket salvo igniting. It sounds nothing like tube artillery, more like a giant zipper tearing across the sky. Flight time, 60 seconds. As commander, I knew the geometry immediately. Each of those rockets packed a 30-40 high explosive rockets do not just threaten a position, they sanitize the entire grid square. And our command post sat dead center of that incoming kill box. Standard doctrine dictates we sever the links and displace, but these drones were not fully cut the signal early, and the aircraft would drift blindly, searching for commands until they crashed. Our entire deep strike would fail before even testing the enemy air defense envelope. We needed 20 more seconds to reach the critical handover threshold where onboard automation would assume complete. This meant holding our ground while 40 incoming rockets arced toward us. 15 seconds. The screech is deafening, not a single whistle but a chorus of incoming steel. 10 seconds. The drones crossed the boundary, automated guidance engaged. 5 seconds. I severed power to the command console. 3 seconds. My operators dove into the transport, our engine already redlining. 1 second. Tires spun as we lunged forward. Behind us, the tree line did not just, it disintegrated in a rolling barrage. 6 seconds of thunder as rocket fire saturated our previous position. The shockwave slammed our vehicle from 200 meters out, shrapnel shredding our tailgate. We punched the throttle. Meanwhile, our 4 drones continued southeast on automated waypoints. My crew survived now, our assets had to. To the south, the enemy logistics train kept rolling at 60 kilometers per hour, approaching the target area where our strike would be most decisive. But enemy air defenses sat waiting on a Russian Tor M2 battery near Starobilsk had been tracking our incoming targets from 38 kilometers out. The enemy held the high ground with an unobstructed radar view across the entire valley. On paper, The Tor is a nightmare for tactical drones tracking dozens of distinct targets with rapid reaction times optimized for low altitude. But a critical tactical bottleneck emerges when swarms present a saturation problem rather than a single threat. While our search radars track multiple incoming returns, actual engagement channels remain. Our fire control can only paint a few targets at once, holding narrow aperture beams locked until terminal impact. Disrupt that illumination for a single second, and our interceptors lose guidance, detonating immediately. Adversary planners designed their attack profiles specifically to exploit this vulnerability. My operator detected a tactical formation engineered to saturate us. One high contact at 2,000 meters flying straight, another threat at 500 meters weaving to disrupt our fire control calculations. Two low flyers at 200 meters utilizing terrain masking as passive armor to evade us. Then, the low threats dropped even lower, skimming at 50 meters, just as our system switched to continuous active tracking. Adversary sensors registered it immediately. Active target tracking spikes radio frequencies, remain exposed, and they take an interceptor in seconds. My team maintained strict fire discipline. We executed our disciplined ripple doctrine. Launch 2, evaluate, re-engage if required. 2 interceptor missiles launched from vertical cell. They did not pursue directly. Instead, they climbed to altitude and dove, leveraging angles to maximize our radar return, while the lead decoy maintained a steady vector straight enough to appear as an easy intercept for our defense system. The lead interceptor's proximity sensor triggered, detonating right on target and reducing the threat to scrap. 10 kilometers out, our fuel convoy cleared the next bottleneck. But defensive victory is never that simple. The tactical struggle continues. Those low-flying wingmen did not just dive, they exploited complex micro. One unit plunged into a deep ravine, pitching up violently when visual sensors detected high-voltage power. Any contact would terminate their assault instantly in a kinetic failure. It leaped over the wires, then instantly dove back to the deck, hugging the deck. To our fire control officer, that brief ascent offered a fleeting tracking window to neutralize those low-altitude threats on the spot. Instead, physics and terrain favored the attacker. This is the ultimate tactical bottleneck. Terrain. The depression ran below local elevation, masking our targets in a blind radar zone. Even with our active electronic scanning, our battery cannot project targeting beams through solid earth. The hostile units entered the gap and dropped completely off our radar scopes. The central threat dove as our next battery launched its interceptors, descending down to 200 meters. Irrelevant. Our system does not aim at current position, but calculates exactly where the intercept must occur. Our interceptor reached the projected kill zone exactly as the target arrived. Another detonation, another threat neutralized. Now, only 2 low-altitude targets remained, and I recognized the true nature of the threat. Those low-flying platforms were the ones carrying the lethal payloads. The high and mid-level targets existed purely to the low pair executed a highly disciplined maneuver, passive but deeply calculated. They ceased maneuvering. Every bank climb or sudden movement spikes radar signature, making our tracking far easier. So they held steady flight paths, minimizing their signature, effectively disappearing from our screens. We tried to reposition the battery for a cleaner shot, but redeploying these we must lower the radar, secure the tracks, displace, relocate, stabilize, raise radar, and recalibrate. That takes 4 minutes if everything goes right. In those 4 minutes, the surviving threats closed 12 kilometers. They emerged briefly at the eastern edge of the valley. We fired again, hitting only empty air as the targets dove into a railway trench. By 0737, both hostile platforms had cleared our battery's engagement envelope. 60 kilometers ahead, our transport reached the terminal zone. At Luhansk, the enemy was no longer blindly guessing. They stood ready. Since midnight, their electronic warfare assets had been deployed near the Luhansk rail yard, shielding their critical refuel. It masked as a standard logistics vehicle until close analysis revealed massed antenna arrays saturating the location. It builds a wall of synthetic white noise, blinding any guidance system that relies on orbital signals. The emitter floods the sector with high-wattage electronic interference, utterly crushing GPS reception within the critical terminal corridor. 0755. Both strike platforms hit the noise wall. From a systems perspective, the impact was immediate. Precision GPS receivers suddenly choked on. Remember, those satellites orbit 20,000 kilometers up. By the time their signal reaches the mud, it is incredibly faint. A tactical jammer nearby easily drowns it out. At that point, the systems flip to inertial guidance, relying on internal gyros to calculate headings from their last. But dead reckoning always drifts. Every minute compounds the error. 5 minutes in, and your bird is off by 50 meters. That is enough to miss the target, striking a minor rail track instead of the train, turning an expensive strike package into wasted fire. This is why we maintain human-in-the-loop control. 180 kilometers away, our pilots watch their video feeds degrade as the frame rates instantly dropped from fluid to choppy, cratering from 30 frames per second down to 10, then 5. Resolution decayed from crisp to pixelated. Latency spiked, meaning every physical stick input took nearly half a second. In electronic warfare, that latency kills. At high speed, half a second means the weapon travels tens of meters before we see feedback, turning precision flight into raw. My pilots must ignore muscle memory, operating like cold machines to dial down exposure and defeat the electronic glare. We locked manual focus to stop the camera from hunting, prioritized frame rate over resolution, and maintained a mental buffer for latency. Our second operator bypassed the color feed entirely. He monitored the battlefield. In combat, steel retains heat differently than earth or concrete. On thermal screens, rail line fuel tanker cars packed with diesel glow as bright, luminous rectangles even through dense battlefields. To our thermal optics, the depot was a glowing tactical map, hot steel rails leading straight into a ladder of enemy fuel cars. The defenders knew their jamming had an impact. On their spectrum analyzer, the enemy operator watched our drone. He tried everything: barrage spot and sweep jamming, anything to break our command link and force a crash. But our FP2 radio hopped too fast. Even flooding most frequencies left fleeting gaps. That was enough for data packets to slip through enough to maintain positive control. Inside the rail yard, enemy troops were finishing a critical fuel transfer, pumping diesel out of the tankers and into underground bunkers. The pumps roared and the hoses remained connected. That terminal was doing exactly what it needed to sustain their frontline advance. Our drones were only 5 kilometers out. At 800 meters, our lead platform struck the third tanker, traveling at roughly 67 meters per second. This was no Hollywood explosion. It was an instant, violent structural failure, looking as if the hull was squeezed to death. Our 105-kilogram warhead delivered a sudden shock load far exceeding the structural limits of the tanker. No chance to survive. Steel ruptured, igniting the diesel into a wide thermal cone. Accelerant flooded the rail line, pooling beneath adjacent cars as temperatures spiked exponentially. Emergency pressure valves ruptured, venting highly flammable vapor directly into the fire in a rapid cascading. 30 seconds in, and 5 massive tankers were fully consumed, feeding the firestorm with thousands of liters of raw fuel. Our second operator exercised. He needed the primary blast to dissipate, giving his thermal sensors time to recalibrate and isolate the target. He had to pierce the heavy smoke to isolate the critical infrastructure node, the transfer hub linking the rail line to main fuel storage. At 30 seconds, the infrared feed cleared. The target outline emerged clearly. The central transfer hub was confirmed. Engaging the target. 20 seconds later, our second drone swept in from the east, vectoring not on the visible fire but directly onto the upwind flank. A calculated approach to spread fire across the compound, maximizing total damage. Highly efficient. Impact at 0801. The structure contained massive fuel reserves and tons of live propellant. The sudden overpressure bulged the concrete walls instantly. Then, the aerosolized mix achieved a perfect critical ratio, triggering a massive thermobaric secondary detonation. 3 kilometers out in Luhansk, the shockwave shattered glass. From my tactical display, the target violently imploded before detonating. The internal kinetic destruction was absolute. Pumping stations failed instantly. Ruptured lines vented high-pressure fire into enclosed spaces that were impossible to isolate, traveling under concrete along conduits and straight into fuel manifolds. The enemy jammers' power levels pegged their electronic warfare systems overheating from overload. Our assault assets had already executed the primary objective: penetrate the yard and turn fuel distribution in. Adversary scheduling had placed their critical supply train there by 0805. In reality, the tactical outcome was decided before their logistics could even play out. Just 60 seconds after the initial impact, the target was completely neutralized, a burning bottleneck for every. The adversary detected the incoming swarm, instantly triangulating our launch vector, and retaliated with a massive rocket salvo. Their air defenses scored several intercepts, but decoy flight paths and low-altitude masking exploited blind spots, causing. Their tactical jamming degraded our telemetry, causing severe data lag, but failed to sever our link, and those two terminal impacts proved decisive.